Hi everybody, welcome back to theCUBE's Palo Alto Studios. This is theCUBE plus NYSE Wired's Robotics and AI Infrastructure Leaders. My name is Dave Vellante, John Furrier's here. We're going to take a little deviation from the whole robotics conversation and talk a little bit about AI inferencing, which is a super hot topic. Mitesh Agrawal is here, he's the CEO of Positron AI. Mitesh, thanks for coming on.
Thank you.
Years ago, David Floyer and I wrote a post, we did a breaking analysis, said that AI inferencing at the edge is going to be the dominant use case, and we can get through training, and that is going to be the biggest market. And it seems to be playing out that way.
Yeah.
I mean, obviously right now, training, tons of money pouring in, but we're setting up for that big wave. What's your perspective on all this?
Yeah, I mean, just confirming that, basically, I mean, we've been seeing numbers from the big companies, right? And Google saying processing 50 trillion tokens per month, which was less than a trillion token, like less than a year ago. So you're seeing literally exponential rise, and that 50 trillion tokens is just right about now. I just saw a study yesterday, about 14% of United States users use AI today in their daily lives. So that's just 14%, and the second country is India at 8.5% or something. So
that's it, huh?
That's it. So,
wow.
so just and
get on board, people.
All of the users is inference demand. So just think about how much more scaling there is from all angles, right? And you think about talking about infrastructure, energy, chips, compute, to actual just end user applications. So there's still a lot more to go, but a lot higher.
What's the premise of Positron AI? Why did you guys, your founders, why did they start the company?
Yeah, I think the main reasoning is exactly that, which is that the inference demand is going to keep on increasing, and inference is a revenue generating activity. So people care about the cost structure for it because they want to drive maximum profitability. And so you basically, from a technical perspective, you want to get as efficient. So performance per dollar, which is your capital expenditure, and performance per energy, or watt, which is your operating expenditure. So you really want to basically design a chip that is really, really efficient for these inference use cases. Now, Nvidia and AMD, especially Nvidia, which is the absolute one of the smartest companies and one of the best architectures out there in terms of GPUs, they're really good at many things, including training, and they're good at inference too. But as applications get larger, as they get more niche, there is so much more room for efficiencies in particular applications that you want to basically drive towards that. And that's where Positron AI comes in. We are basically an ASIC company designing for inference workloads in the beginning, really honing in on architectures like transformer architectures, which are basically the driving force behind today ChatGPT and other LLMs that are out there, like DeepSeek and Mistrals and Llamas of the world. So we are really designing a chip that is fundamentally focused on driving that efficiency value, so performance per dollar and performance per watt. And we really think that we have a unique design architecture on the chip side, as well as a very, very appealing software story, such that we can, for those applications, be highly competitive to the existing offerings out in the market, and obviously be better than them. That's how we get market adoption, and that's kind of the focus for the company.
I want to ask you, because when Jensen speaks, we all listen.
Yeah.
And he on his earnings calls, he'll say X% of our enterprise business was inference.
Yeah.
Presumably that's a lot of ChatGPT, and that's a big number. It's like 40%. And so you hear that, and a lot of people might think, well then Nvidia is dominant with training. Why aren't they going to dominate inference? And he'll talk about how, well, you train and then you infer, you train and you infer. And so help us understand. I mean, I think it does come down to the economics and the efficiency.
Yeah.
And then I want to get into what's unique about your ASIC.
Yeah. Yeah, I think to your point, kind of to extend that, right? Like, absolutely today, when you train, Nvidia is the go-to, right? No questions asked anywhere. And then people continue to use Nvidia GPUs for inference, rightly so. They're top of the line, H100 a couple of years ago now, Blackwell series, and then upcoming Rubin, right? Really top of the line performance and things like those. But I think one of the conceptions in the market is that, if you train on something, you have to continue to infer on that same chip. That's not the case, especially, I mean, today that's the case because both Nvidia is top of the line in terms of performance, but then also they have the CUDA stack, which is an absolute phenomenal piece of software that everyone uses, right? So it's the workflow, everyone is accustomed to it, it's all installed there. This is where kind of Positron steps in. It's like, we are saying that absolutely do your training on Nvidia, But then if you want to run inference, we can drive much better performance per dollar and performance per wattage compared to NVIDIA cards with our current first-gen cards, and then obviously with what we're going to be launching in the future. And the software piece of that is what we're telling, and this is one of the unique pieces about us, is we basically are telling our customers, and they have experienced this, we have real customers that we have deployed with, basically they have to make no changes from the workflow that they already do with NVIDIA cards when they do inference, and just swap NVIDIA cards instead of Positron cards and Positron systems, and you'll be able to run similar inference, like no code change.
Really?
You don't have to compile anything, but we're focused on the transformer architecture, right? So for that inference applications, we are kind of plug and play compared to that. So that's the software USP, and then on the hardware design side, it's the unique IP design on the chip design itself, like how we are processing the data, and then the memory architecture that's allowing us to drive that higher efficiency there. So that's kind of the two things that we're focused on. And it's not like a fact that, you're not saying, obviously NVIDIA is going to continue to be the dominant kind of silicon provider of the world, but it's around, as applications grow, the market is going to keep on growing, and then you find these applications where you're going to be better than them because you're focused on certain efficiency metrics, either on hardware or software side, and that's kind of how you drive our market presence and our growth.
Yeah, and they're maybe not going to optimize for that use case. But,
yeah.
So you speak CUDA, is that right? You speak?
So I want to be very, very specific about it. So what happens is we plug in right into the NVIDIA ecosystem. So what I mean by that is when you train a model, you get a file called .pt or .safetensor. That's what you upload on Hugging Face, which is the raw weights of your model, right?
Yep.
And then when you're running inference, you upload those raw weights onto the NVIDIA GPU, and then it has its own backend, and then it basically gives you an API against which you can hit tokens, and you get tokens out. That's kind of what you're using the chatbots. So we do the exact same. We take those raw weights and upload it on our system, and you get an API out that can do the tokens. So from an end user, like from an engineering perspective, uploading the raw weights either on NVIDIA system or Positron system is exactly the same. So the workflow is exactly the same for inference. Now, we are focused on only transformer library that is there on the Hugging Face. So you can do that for that, but if you have some other type of model, like for example, today, like if you're wanting to run diffusion models, today we don't support it out of the box. So I want to say that yes, we are part of the NVIDIA ecosystem, but it's not because we have somehow tapped into CUDA or anything like that. Because if we had tapped into CUDA, then we could support everything underneath the sun. But no, it's because of we're taking the output of the NVIDIA training run, and which is what NVIDIA GPUs also do to run inference, and we're doing the same exact thing. So we're part of it. What we're not making customers do is, hey, you have to compile this model to, every time a new model launches, you have to compile it, or even if you have to do fine tune, you have to compile it or change some code. We don't have to do that. Because of that, we are very widely usable within that transformer library.
This is the workflow that's really plug and play.
Yeah, exactly.
Okay. And then tell me more about your ASIC. It's so interesting, the silicon business, how ARM and TSM have just changed that business. John Furrier used to joke that theCUBE is going to design an ASIC. And VCs used to never want to invest in that. Now it's
from
just
hot to cold to hot, yeah.
It's very hot right now. So tell me about your architecture, your memory architecture, your high bandwidth memory, or what's it look like?
Yeah, so we are really focused on, when we're thinking about transformer models, they're fundamentally matrix multiplication, and even within that, they're, on the inference side, they're matrix vector math. So basically, you really want to have very high memory bandwidth. You obviously need a certain level of flops and compute, but you also need very high memory bandwidth because you have to move a lot of bytes of data for using those flops. So because you have to move that, you need high memory bandwidth. Now, with a lot of cards out there, including NVIDIA cards, they use HBM memory. So the theoretical memory bandwidth available is very high. Like, for HBM3, it's like 3 terabytes per second. But when you actually run that for inference jobs, the realized memory bandwidth is only 1/3 of that, roughly 30% or so.
It can't take advantage of the architectural, it can't get close to the architectural
architecture cannot take advantage of all the actual memory bandwidth available. Whereas for us, the architecture takes advantage of it, and we can drive over 90% of the available theoretical memory bandwidth that is there. So we can really drive high memory bandwidth, which allows us to flow more bytes of data into the compute, and as such use compute at a much higher utilization ratio. So this basically lowers our performance per watt and performance per dollar because for from a use case perspective. But that's the fundamental kind of 40-feet view of what is driving really the innovation on our side. It's not like new physics, like we're not doing optical or quantum or anything. It's silicon. It's new silicon. It's a new design for silicon, but it's basically how the memory management and then the fundamental elemental unit of the chip, how we process that compute flow, is kind of what we're driving the real performance. So as a first step, what we did was, a lot of ASIC companies, this is one of the key things. We are very much product and customer focused in the sense that we want to get products out in the market as quickly as possible. So a lot of ASIC companies, they have an idea, a lot of times brilliant ideas, and then they take 2, 3, 4 years to really come out with their first product in the market. ASIC companies just take time. What we did was, for our first product, we got out in the market in less than 15 months with just seed money amount of raise, and what we used was an FPGA, which is a programmable gate array card, and we basically designed our architecture on top of FPGA, and showed to the world that our architecture actually works and drives really, really high performance. So today, for a lot of the Llama model ecosystem, the open source model ecosystem, we can drive anywhere from 2 to 4x performance per dollar and performance per watt efficiency over an Nvidia Hopper H100 card. Now, obviously, we have to stay up to the market. Nvidia is already on Blackwell. So our ASIC that is going to come out is going to really drive competition against the Blackwell and Rubin cards of the future. But we already have our shipping, and we have shipping our first product out already.
Because you built on top of an FPGA, if I'm saying that correctly.
Correct.
The programmability of your ASIC, does that have implications on time to market and how long it takes you to, maybe you don't have to do tape out every next generation?
So when you're building on FPGA, that does allow that, because FPGA is technically already taped out, and
right.
Yeah, right. So that did allow us to get our first product out so quickly, and this allows us to learn from our customer use cases and then take that to ASIC. But FPGAs are that, if you talk to anyone in the industry, they'll say that FPGAs are not going to be a long-term solution to drive efficiency. Rightly so from a specific application, because FPGAs, you can put your hardware architecture on it, but it's not going to be the most efficient in terms of the brute specs of it, like the flops available, the memory available, the type of memory flow. So you have to design an ASIC with it. But at least what we have done is proven out our product and actually deploying it in production environments to show that, even with those limitations, we can drive this much higher performance. So when we design a specific chip for it, we can drive even more. So you do have to do the tape out process. And that's why ASIC companies take 2 years, 3 years, 4 years to come out with a product. But we really wanted to get a first product out, get real feedback from customers, and then drive that into our kind of ASIC design and ASIC outcome.
What are the use case patterns that you're seeing evolve?
Yeah, I think the primary thing today, because it's a little bit biased too, because we are supporting transformer architecture, you're looking at mostly then text-based models, so LLMs, whether it's in chatbots, code generation, so what we do as a company is we target the general purpose underlying of it, so inference as service providers, for example, or certain niche applications that are large enough, whether it's in-game content generation or code generation. Especially, we are really good at generation part of the LLM inference stack. So these are the primary use cases driving it. But if you think about it, chatbots are fundamentally used in so many different types of verticals, like all the way from serious enterprise businesses like healthcare and financial tech to all the way like consumers like role play and things like those, right? So fundamentally, but that's just underlying is in large language models. So that's what we are powering through general purposes. So we just announced an offering through Paracel, for example, which is an inference as a service provider. And they have users that use a lot of different types of use cases. One of the key things for us is we can host many, many models on the same card. So on a GPU, generally you're hosting one model per GPU, and then if you want to swap it around, you need to load it, and it takes some boot time, whereas our architecture allows many tens, hundreds of models to be loaded at the same time.
Okay, so you can target those vertical cases much more rapidly.
Exactly. Imagine you have a fine tune for you, which is your assistant, office assistant. I have a fine tune for me, which is my office assistant. And instead of dedicating a card to each one of us, basically the company that is serving it can put all those models on the same card, and then depending on the use case, can scale that up or down if you're constantly using yours and are having a lot, then they can dedicate more cards to you. But the model is always active on a single card.
Where are you in your go-to-market? Do you have product market fit? Are you scaling your go-to-market?
So yeah, I mean, we are a young company from ASIC timeline perspective.
Yeah,
We're 2 years old, and we launched our product roughly 4 to 5 months ago. So right now we are very early in the case of product market fit. If you might want to say, I consider product market fit as having huge amounts of revenue. We're talking about hundreds of millions of revenue, right? But right now we have early customers that we have deployed with. There's few of them have converted to production customers, few of them are still in proof of concept. So that's kind of where we are currently at. We are really driving that over the next 6 months into the market with our first generation product. And then while in ASIC world you never sleep, you have to always think about the next and the next product for it. But in the terms of product market fit, today what we have shown is a real performance advantage for our architecture. And that's kind of what we're driving initially with our customers.
Yeah, and that has implications for your go-to-market. I mean, you don't want to scale your go-to-market until you really have nailed your product market.
Exactly,
so you're very intimate with that go-to-market, I would presume.
Yeah.
You're consultative selling,
yeah,
right?
Yeah, and it has to be right now because we learn as much as we give the product and the more people that use it. And then the second thing is also just around practical scaling, right? Actual supply chain production, actual ability to have the balance sheet to scale that out and things like those. That comes from continuously building your sales pipeline and raising.
And you haven't raised a ton of dough. Is my data right? You'd raised like 23, 24
Correct.
million?
Yeah.
It's very efficient.
Yeah, we are very, I think one thing we can be a little narcissistic or proud about in a way, is that our capital efficiency. We launched our first product actually when the company only had raised 12.5 million. And again, if you look at the ASIC company's background and history, generally it takes hundreds of millions to get a first product out. So we're very proud of that. Obviously, you can imagine that showing that capital efficiency continues to drive what we're going to do in the future and allows us to raise more. But yeah, we have only publicly announced raise of $24 million, and really have gotten our first product out with customers and real paying customers, and then are going to continue to build on our next ASIC.
Well, excellent. Congratulations. Really appreciate you coming on theCUBE.
No, thank you for bringing me on.
And then energy, I mean, performance per watt, it's the big blocker right now.
Yeah, I mean, that's probably, I think, infrastructure world is right now really looking at it very deeply, and I'm sure, you're talking to Chase after this.
Yeah, exactly.
So
he's living it.
Exactly, he'll enlighten you. He's one of the best people out there about it. But yeah, I mean, driving, first of all, period, we have to grow out energy production. So there's no two ways about it. But whatever energy we do have, we should drive as much performance out of it too as well, because neither of those will be enough for what is coming.
Right.
That's what it is.
All right, Mitesh, thank you very much. Appreciate
Thank you.
it. Stay right there. Okay, and thank you for watching. We'll be right back right after this short break. This is Dave Vellante for John Ferry and the entire CUBE team, theCUBE plus NYSE Wired. You're watching our Robotics and AI Infrastructure Leaders. Right back right after this short break.